Hello everybody. Over the past month, I've been getting an increasing number of questions from people all over the internet asking about higher voltages or printers, making printers go faster, and how did you do that, and what are the details? I've been a little reticent to give some of those details out because I am not an expert. I actually don't have a diploma or degree. I just am a technical guy at nature. I'm actually a database administrator, so I've got a pretty good technical acumen, I guess, but I'm in no way an electrical engineer or an expert on any of this stuff. So I'm learning as I go. So I've been a little reticent to give out too much info, and with the worry that I'm giving out bad info. But I've had enough people ask me questions, and I have gone at lengths to answer all those questions. I'm a nice guy. If you hit me up with questions on Discord, I'm probably going to give you good answers. I'm not going to put you off. So I've done that enough that I feel like either A, I've done enough damage already and I can't do anymore, or the info I'm giving out is going to be good. So I thought it was time for a quick video. So this is going to be a video about doing a higher voltage on your 3D printer with the goal of making your printer go fast, making your printer go faster, getting more power out of your printer, making prints faster, that sort of thing. Get a lot of these kind of questions. And I've obviously done some of these activities is the reason I get the questions. So I've got a quick little impromptu list I'm going to go through here. We're going to look at my 2.4 is in the background here. Really sorry about the quality of the wiring. Just bear with me. And then I'll swing around over here is going to be the K2. I have the back of it showing, and I'll show you there's another higher voltage option on it. And then we'll jump quickly into, we might jump into firmware if we've got time. I try not to make these videos too long. I'm already over 2 minutes. So let's go, let's hit through the list real fast. I'm hoping that these will answer a lot of the questions or insecurities that people have about looking at this type of system and whether they want to do it. Not everyone really should be running these type of systems. A lot of printers don't even benefit. So let's go through them. So how did we get here? Why is this topic coming up? What's the deal? So 4 or 5 years ago, I would say 3D printers were all pretty basic. Now this is actually a CNC shield, but a 3D printer control board used to look kind of like this. It would have a Arduino based board underneath it and a top hat that would go on top. You put your steppers in here, and this board was usually real basic. I wish I had a ramps board to show, but I've thrown all mine away. But a ramps board was very popular a number of years ago. These systems typically took 12 volts and may or may not have even been capable of higher voltage, but that was kind of the norm. You run your printer on 12 volts. 12 volts is kind of like the normal voltage for everything, so that was easy for people to get into. So I don't have my timelines in front of me, but 3 years ago, roughly 2-3 years ago, we started getting 32-bit boards, and we started getting 24-volt boards about the same time. And people kind of not found out, but people started applying the knowledge that higher voltages meant less amps, less heat. You can run higher wattage components at 24 volts. And the other aspect of that was that steppers, and we have these standard steppers, like this is a NEMA 17 stepper. Had these for years and years, but with these new style drivers and the newer boards, we could run them at higher voltages. So these stepper motors, to turn a stepper motor, you're turning on and off coils. Wish I had one taken apart to show you, but there's basically just a huge amount of wrapped coils in here, and there's 4 wires. There's 2 wires per coil. There's two distinct wirings for the coil. As you turn those coils on and off, that's what makes the rotor inside spin around. So you're putting varying voltages to the coils, and that makes that rotor travel around the inside. That's the motion. So there is and again, I am not an electrical engineer, not an expert, but I'll explain it in layman's terms. It's the way I know it, the way I'm going to explain it. These coils have a resistance to being energized and being turned off and reverse current applied to them, which happens really fast when they're turning this motor. This motor has 200 steps per revolution. So that's 200 flip-flops of the coils for each revolution. It's a lot of change in current up and down, back and forth on the stepper. There's a resistance to that. So the bottom line is your stepper will only go so fast for a given voltage. So let's say, I'm just going to throw it out here. Let's say this thing will do 300 millimeters a second with your belting and 12 volts. That's all it'll do. You can't go beyond that. The stepper and your board and your combo won't make this go any faster. But if you swap from 12 to 24 volts, then this stepper will go roughly twice as fast, give or take a little. So all of a sudden, instead of 300 millimeters a second, now this motor and thus your printer, as long as your printer can handle it, your printer will go twice as fast for upping the voltage. So we've been on 24 volts for a while. It's pretty well understood. Pretty much every printer has 24 volts. So some people are now pushing beyond 24 volts, and there are some limited amount of hardware to support that. And the cool thing is that there are stepper drivers that support it. So we've been able to jump up and do higher voltages, and the benefits keep going up with these steppers. Now, one caveat I will give is that some printers are not going to be capable of using that speed. First off, you can only extrude plastic so fast, so maybe going 200-300 millimeters a second is already beyond what your printer can do. Then this won't help. The other thing is that that's pretty much it. And the other thing is, of course, your printer build, right? How rigid is your printer? Can your printer take jerking back and forth and all over the place at those speeds? And do you want to do that to your printer, right? So there's some considerations here. But for those of us that have rigid printers and want to explore kind of the upper end of speeds on what we can do, then this high voltage stuff is really cool. And so there had been some interest in doing that. So let's see. So we talked about the boards. We talked about the 8-bit boards. We moved up to 32-bit boards. This is a Big Tree Tech Octopus. The cool thing about this board, and it's going to come into play in here in a minute, we'll talk more about it. This board actually has separate voltage input for the steppers. So over here on the upper right, these top two terminals are just for stepper motor current, not for logic. It's just for what drives the motors. It comes in as a separate input. The cool thing about this is that you can actually pump a few extra volts into this, and it makes it easier for a board manufacturer to go back later, and Big Tree Tech is doing this, going back and looking at this board and saying, we can make like a cooler version of this board, and we could up the capacitor ratings on the board and just make a few little changes, and then we could allow people to put in higher and higher voltages on this board. And that's actually happening. Big Tree Tech is coming out with the Octopus Pro. There's already some marketing material out there about it. It's the same board, but it has a few upgraded components and higher capacitor ratings will let you run higher voltages. So Big Tree Tech has several boards in their lineup, and I really do like their lineup because they have early on have allowed for separate voltages for steppers. Let's see. So let's talk real quick about power supplies before we go into the rest. I'm going to kind of read the riot act, I guess, on power supplies. So this is your typical Chinese, I shouldn't say Chinese, this is your typical cheaply made budget power supply. All right, it's like no name, no label. This actually is it's 12 volts, 30 amps, 360 watts. I wouldn't trust 30 amps coming out of this thing. Don't use these. If you're going to do anything with high voltage, don't use cheap components. I'll just say that. Don't use cheap components. I'm guilty of this too. I'm not any better than anyone else. I have cheap components here and there too, but don't do it, especially for the power. You're going to want Meanwell power supplies. I recommend Meanwell power supplies. If you look at Voron or just any of the teams out there who are putting out bill of materials for building their DIY printer, they're going to have Meanwell power supplies. Just full stop. So this is a LRS 224. This is a 24 volt, 200 watt. And what I'm going to show these come in all different voltages. So you can get these in whatever voltage you want. So this is the spec power supply for a Voron. And the other power supply that I will show, and I've begun to like these better than the LRS, is UHP power supply. A UHP power supply is a smaller, more, I believe, more durable power supply. These all don't need fans, so that's one thing. But this one, actually, I'm really liking this one. First off, it's super compact. You give up terminals, so you only have two of the positive, two of the negative. You have less terminals. But this power supply is really nice. It's very compact, and it is, I believe they call it conformally coated, but everything inside is covered with a waterproofing or moisture proofing resin. I think that's actually for heat dissipation, not really waterproofing. But you can see here the case is also doubles as a heat sink. It's got these ridges on it. All right, so that's enough about power supplies. Use Meanwell power supplies. They come in all different sizes and all different voltages. The ones that we're using for our hobby printers are either going to be LRS or UHP. You can get these electronics warehouses. In the US, it would be DigiKey or Mouser would be the two good ones. Actually, Amazon sells these too, but beware getting these from Amazon. Only buy them from new, sold by Amazon, not just fulfilled by. Don't get a clone. Don't mess up and get a clone. DigiKey and Mouser are going to have only the OEM stuff. So, all right, so power supply talk is over. So let's talk about step sticks real quick. So your 3D printer, so first off, if you're doing any playing or DIY, you're going to need a board like this that has stepper stick slots. That's step A. If you don't have that or don't understand what this is, then you probably shouldn't be attending this TED Talk. So the steppers go in here. Two of the pins on each of these sets of slots give the high voltage, not high voltage, the motor voltage into the step stick. And then you've got 4 pins that come out into here. So this is the one that people are most probably running more than anything else. This is a TMC 2209. It's kind of like the de facto stock choice of stepper drivers right now. Well, most people are going to be running these. They're rated, I believe they're rated up to 28 volts. Basically, they're made to run on a 24 volt system. That's what they're designed for. These are pretty good. They have a current limit of roughly 1.4 amps, give or take, on their cooling. They do run hot if you run that much amperage, and they can only do about 24 volts. Your next step up in drivers. So this is option 0. This is what's on your stock board. This is what's in your stock printer, most likely either 2208 or 2209. So if you're not comfortable with higher voltages and all the aspects of doing this kind of wiring, then this is what you're going to be using, is 24 volt system. This is option 0. This is what you already have. The next step up from that is going to be a 28 or 35 volt system. And so this is Big Tree Tech's 5160. It is it's not a clone, but it's a close copy of the original Silent Step Stick 5160. It's made in Germany by a company called Waterot. So Big Tree Tech has made a version of that you can buy on Ollie in your normal places. These drivers are extra cool because the MOSFETs, the part that does the power switching, is not on the chip. On a 2209, the driver chip, that's the square chip in the middle, it's doing all of the switching, and there's no other heat generating components on here. So the chip, that small square chip in the middle, is generating all the heat, doing all the work, and it gets hot. On a 5160, I think it's fairly unique in the step stick world, 5160 has external MOSFETs. So you need a MOSFET to switch DC voltage, positive, negative, negative, positive on each wire for the stepper, each 2 wires, and you need 2 sets of those. So you're going to have 4 MOSFETs on these. And you can see here the small black squares, those are the MOSFETs. The pad in the middle, the copper pad in the middle, is a heat sink for the driver. And the driver is underneath the chip on this one. What's cool about these is that they can push more amps without generating as much heat. So I push amp and a half through these on my K2. They do get warm, but I don't need a fan. They stay cool enough without fan power. If you get the original, so that's the Big Tree Tech 5160. This this silent step stick is limited to the capacitors on the board, as is this board I'm holding here. They're limited to 35 volts, and the reason for that limit is capacitors. They all have 35 volt rated capacitors. You don't want to usually run your voltage close to capacity on capacitors, or the ratings on capacitors. So I generally recommend people run about 30 volts on these systems. That goes for the Big Tree Tech driver and this Octopus board. Big Tree Tech is coming out with high voltage versions of both of these, the board and the step stick. Those will be out in the next month or so. I hate doing this video right now because they're just about to put out these new products, but that's currently the Big Tree Tech stuff is 35 volts. It will be 48 volt capable in the next few months with they're calling it their Pro models. So those are coming out. The other option is full 48 volt option, and I would just talk about Big Tree Tech is coming out with those. But you can buy a 48 volt option now. It's very limited. You can only get it from one place. It's from Waterot in Germany. They're the people that came up with the silent step stick, the father of all the step sticks that we run now, 22As, 2209s. They came up with the packaging to put them on the step sticks in those new forms. So this is a 5160 HV. So this is capable of 48 volts on the chip. Now, the challenge with this is that this chip is, or I keep saying chip, the step stick, this board, it's capable of 48 volts. You can put 48 volts into the corner of this driver, and then the rest of your logic pins out to the board with this not connected to the board. And you connect all that together and then drive your steppers at 48 volts. There's no other configuration you have to do either. It just happens. So that's cool, but the problem is right now no boards support feeding power to the step stick. Any board that you put 48 volt in that is not rated specifically for 48 volts, and you've checked the capacitors have to be 63 volt capacitors. If you don't have capacitors of that voltage, or your board does not say it's 48 volts, you will pop the board. You will immediately fry the board with 48 volts. So there are some ways around it. Use these, and I do this on my Voron. I'll show this. So this is the basic premise of what you'll do, and this is exactly what I've done on my 2.4. You take, so these boards from Germany, as it turns out, luckily, come unsoldered. So they send you the header pins, and you solder your own header pins. So what you'll do is you'll push two of the pins up, and this is what I've got on the Voron. I'll show in just a second. But this is the basic premise, is that you're putting in your 48 volts in here. This is the motor voltage. And then the rest of the pins still connect to the main board and function as normal. I'll give a couple quick warnings about what I'm showing you here. One is I got away with doing this on my 2.4 because I only needed two high volt steppers, the X and the Y. It's the only two steppers that are high volt in the system. If you're going to run a whole board full of these, you're going to run 4, 5, 6, 8, 9 of these. Your board has smoothing capacitors for each of the step sticks are on the board, and TMC wants you to run these. I got away without running these on these because I had a dedicated high quality power supply supplying these. The wiring run was short, and I only ran two of them. So I got away without putting capacitors on. You're going to run more than two of these. I would recommend that you find a way to put smoothing capacitors on these. That's beyond what I'm going to show you. That's beyond what I have tried myself. But you know, there's your warning. Otherwise, I would say actually wait for boards that can support these steppers. And Big Tree Tech will have the steppers and the boards out soon that will support them. Mello has a 3-port high volt board that they just came out with. Has three of the step 6 slots are able to run high voltage. Big Tree Tech is going to come out with a version of the Octopus, and it is going to have all 8 of these slots high voltage. So let's show what these look like. So first what I'll say is I showed you putting the 2 pins up on the drivers, and I wouldn't do that again because you can do damage that way. The problem with doing the 2 pins like this is that you have to use DuPont pins, which are not locking. So the 2 pins go on top of the steppers. They don't lock into place. And that is a little dangerous. And I'm going to show, I actually did that on my 2.4, but I would not recommend doing that again. I would actually recommend doing one of these 2 methods, depending on the connectors that you like. You got your JST 2-pin, or you've got a Microfit 3 surface mount 2-pin. They both have the right spacing to sit on the step stick. They do hang off to one side. And it's not optimal because these actually do touch the MOSFETs on that end, but these are going to run for your hobby steppers. You're only going to be running 2 amps or less on these hobby steppers, so you're not really pushing these drivers. So you'd be able to get away with this. But I advise locking connectors, either the JST or the Microfit. So that's how you pump in voltage to these boards without your main board supporting it. All right, so I've showed this. Now I want to show a couple of examples, a couple of real-world setups. I've got 2 of them. I've got 2 printers here, and I'm going to try to move this camera without making you sick, but I'm going to show 2 wiring samples of getting higher voltage into a printer. So the first one I'm going to show here is my Voron. So this is a purple machine. This is the Benchy machine, right? So let me zoom in here. First thing I will show is the 48 volts. So this is a Meanwell LRS 100. It means it's 100 watts, and this is a 48 volt power supply. So I am pulling 2 positive and negatives off here and feeding that down here. So this is a SKR 1.4, and those are the 2 high volt steppers. And as I said before, I am feeding these with DuPont pins. They're non-locking. I would probably go back and do these with JSTs or Microfit 3s if I was doing it again. But that's what it looks like. So the two wires going into each of the steppers, it's got 48 volts and ground on it. Those do not feed into the board. You cannot feed that voltage into that board. It'll just immediately pop the board. You won't have any stepper wire control. Any stepper motor control, no power on any of the sockets, and you may do other damage. You'll definitely let the smoke out. You won't be able to put the smoke back in. So that's what I do on the Voron 2.4. And I will show the other sample that I have here. Let's see. And just be kind on the wiring. I am not great on wiring. I never said that I was. And in addition, the K2 here is actually in the middle of being built. I have the motion system working, but the tool head's not wired. So this is what it looks like on an NX K2. This is the middle voltage option. So I am using Big Tree Tech SKR Pro 1.2 at the top middle. And then right beside it, connected with the yellow ribbon cables, is a Big Tree Tech EXP MOT. What that does is it lets you sacrifice your display connectors and use those for more steppers instead. So the main board has 6 steppers and the expansion port has another 3. This printer needs 9 steppers. It has that many steppers. So again, as I said, this is the middle voltage option. So what I've done just for to make the wiring easier, I know the wiring looks like a mess, but it could be a lot worse. I am putting 30 volts of power into the SKR Pro 1.2 and the EXP MOT. They can both take 30 volts on their stepper input rail. They both have inputs just for stepper power. And I'm utilizing that. I'm putting 30 volts in. 30 volts over 24 is an extra 25% boost in your speed limit on your steppers. So I can run the steppers on this machine 25% faster. These, I'm using Big Tree Tech's 5160s. The other thing about the 5160s is that they can push more amps. and I'm running higher amp steppers on this printer. LDO is coming out with 2.5 amp capable steppers, and I've got 4 of them on this printer. And I'm able to push 1.5 amps of run current on those steppers right now with this board without any fans. They don't shed a lot of heat, so it's really nice. If you look at the bottom of that chassis, you'll see, you'll actually see 2 of these UHP power supplies. They're on edge, but there's 2 of them there. One is a 200 watt 24 volt to run the main board. The other one is a 200 watt 48 volt. What I've done is I've ran that through a high amperage buck converter. And that's the little circuit board with the blue light on it that's sitting on the rail just above. So it's rated for, I think, 10 or 12 amps. It's rated for more amperage than I need, and you definitely want to overspec when you buy a cheap circuit board like that. But it is taking the voltage down from 48 volts to 30 volts. So I'm running this setup for the next month or 2, and I expect there to be some board solutions out in the next month or 2 that will let me run 48 volts on the board. Annex Engineering is coming up with a cool 4-stepper board that runs a Pi Pico that I'm definitely going to be trying out. And then Big Tree Tech is coming out with their gear, and I will likely end up with one of those. I've already begged them to send me one to evaluate. Said they will, so we'll see how that goes, but I'll definitely be making use of their Pro line of boards as they come out, and I'll take this printer from 30 to 48 volts, so that'll give me lots of crazy movement power. I think that's going to be about it. I want to give one more call out about the steppers. When you're looking at 5160 steppers, that's the other thing that I get a lot is, okay, I want to get these 5160 steppers, and people get them in, they're like, how do I work these things? These things are, they're weird. What, I don't know how to put them in. So if you're somewhere in the middle, you're kind of savvy, but you haven't ran these boards are SPI. So there's a different config on your board, and somewhere like a Big Tree Tech, they'll have instructions on how to set up SPI on these boards. But you'll need to swap these over to SPI. And there's a set of jumpers for each stepper that you need to swap over to run these. In addition to that, and this is just a one-point experience for me, but I've been running these Big Tree Tech 5160, these regular low middle voltage 5160s. These are not an exact copy of the water rot steppers. They're a little different, a little programmed a little different. I'm not sure exactly what, but you will need to run a set of TMC flags in your config for this. All of that is way beyond what this video can show you. I'm already running on 30 minutes. This video is way too long. But just beware that you'll need to understand how to configure your steppers for SPI. There are jumper differences, and you'll need a board reference to program all of that in, and your clipper config will look different. There are example clipper configs for SPI and for UART on Kevin's site. There's examples for each one of the boards, so you should be able to figure it out. But just know that you will have to figure out how to talk to these 5160s a little differently. All right, so having said that, I've ran way over. This video is way longer than I like to produce, I guess. I don't edit my videos, but I try to keep the length of it down for people with internet attention disorder. But look, this video is 29 minutes long. I'm going to cut it off here. I hope that answers some questions that you have. If you have more questions, please put them in the comments below. Let me answer them, and then I will also put anything I missed into the description of this video. So if you're watching this video at a later date, you think I may have missed something or you have questions, I would advise you to look in the description first and look in the comments, see if you can find your answer there, because this is an evolving thing. It's kind of a new thing for 3D printer hobbyists. So I will update the info as it becomes available. Just look in those places. I hope this helps you. Thanks for watching the video.